In order to build a momentum trading model, there are 6 steps involved. The first step is to define the problem. Although you may think you know what the problem is, you must learn to define the problem in terms that can enable you to use a machine learning algorithm. That's what we are going to do in this step. Let's review once again the key elements of building a trading system. First, you need to identify a strategy, decide which markets you want to trade, develop the logic with which you want to trade them, and define the parameters by which the trading logic is triggered. Second, you need to backtest the strategy, analyze your strategy's performance on historical data, and remove biases. Third, execute your strategy, link to a brokerage, and minimize the transaction costs, cost of trading, commission, slippage. Finally, manage risk. Create pre- and post-trade checks to avoid losses. The good news is that you are responsible for 2 of these elements, strategy and risk management. The remaining 2 elements, backtesting and execution, will be done by the open source library Aquan Toolbox. To develop an ML-based trading strategy, you need to decide what problem you're going to solve. That is, decide which markets you want to trade, what will be your target variable, develop the logic with which you want to trade them, and define the features by which the trading logic is triggered. In many cases, traders want to simply predict a price. In some cases, they want to predict a return. In other cases, they simply want to know whether to buy or sell an asset, what's known as a binary decision. Then there's portfolio optimization, which is where portfolio managers make buy and sell decisions on a number of assets in their portfolio, sometimes simultaneously. Finally, there's the problem of deciding where to buy and sell, what's known as efficient execution. You want to find out which markets or exchanges or brokers that you want to route your trade into. Each one of these problems requires a different data set. Sometimes the same problem may be attacked from multiple angles using very different data sets. Now let's look at how we can implement our momentum trading strategy using machine learning. To do that, typically in a trading firm, we would need a huge infrastructure: servers, networks, data feeds, expensive programmers known as quants, and a backtesting engine. Fortunately, it's 2019, we can mimic most of this infrastructure using Google Cloud Platform and an open source library known as Aquan. Aquan is a new data science and machine learning platform for financial services. They have an open source library called Aquan Toolbox that will allow us to implement our momentum trading strategy with minimal code. Let's see how we can do that step by step in the next few minutes. In this lesson, we're going to use a problem from Aquan's website called QuantQuest. Aquan's website has a separate section for data scientists who want to develop algorithms for trading. That's perfect for us. To do that, Aquan holds competitions which allow data scientists to develop a trading strategy using ML or otherwise to solve challenge presented in the competition. They help you win your prizes or a chance for a job interview by leading recruiters. In our case, we are simply going to learn how to solve a simple trading challenge. If you want to try more challenges in the current or previous competitions, go to the website aquan.com and register yourself and click on the Data Scientist button as soon as you log in. Then you can see the present and previous competitions there, as you can see in the image here. Today, we are going to create a prediction model using machine learning to solve a challenge: how to predict the future expected value of a basis. Well, what is a basis? A basis is a difference between the current price of a stock and the price of the same stock in futures markets. In this case, a single stock futures market. Since our company is fictitious, we assume it trades in a futures exchange. You can substitute this data with any real data you have for any asset from a current price and a futures exchange. For example, spot prices versus futures prices for a currency. Next, know our prediction goal. Let's define our target variable. We define the target variable y as the average of next 5 values of basis. That's right. The goal is to predict the average basis 5 minutes hence. We saw in an earlier slide that to create an ML trading strategy, we need data, lots of data. The more data we have, the better. But since we are going to make this simple, we are going to select a small amount of data that's reasonably realistic in order to develop a simple trading model using machine learning and see how it performs. First, we are going to use Aquant to download some historical data. In this case, we are using the following data for our problem. Stock prices of a fictitious company whose trading symbol is MQK at 1 minute trading intervals for trading days over 1 month. That is 8,000 plus data points. It has columns for stock bid price, ask price, bid volume, and ask volume. Future bid price, ask price, bid volume, ask volume, and VWAP. If you don't know what VWAP is, it is the volume weighted average price of a stock. To calculate a stock's VWAP, we multiply bid price by ask volume, add it to ask price multiplied by bid volume, and divide the whole thing by the sum of ask volume and bid volume. Similarly, we get the same for the future VWAP. In many cases, you will have to get this kind of data from multiple sources, clean it, and make sure it's adapted for dividends, stock splits, etc. The good news is that that data is already cleaned for dividends, splits, and rolls from Aquant. Here's how a sample of our data looks like. The left side is the index or the date and the timestamp of the tick data. The columns are for stock and futures prices. The basis is the calculated field, and Y is the target variable, another calculated field. The way we are going to set up this trading strategy is similar to how we set up an ML model. We create features which could have some predictive power X, a target variable that we'd like to predict Y, and use historical data to train an ML model that can predict Y as close as possible to the actual value. Finally, we use this model to make predictions on new data where Y is unknown. To create Y, we need to create an average of the first 5 basis values, which is a feature, let's say X1, and put it into the cell called Y6. Similarly, we will compute an average of the next 5 basis values and put it into Y7, etc. Since our goal is to predict the average basis 5 minutes into the future, we need to create an average of the first 5 basis values and align them to the first row or the first data point. Then we do the same for the next 5 basis values and align them with the second row and so on. This means we are creating a moving average of basis values with a period of 5. This method is typical of how we predict in time series using ML. We take values into the future and align them back with current values. That way, when we need to predict 5 minutes into the future at some point, much later in time, we will feed the current values of our features and voila, the model should predict what the future value of basis will be. Hopefully you got this important point. If not, please rewind and review how we set up the X and Y variables for this data point until you understand it thoroughly. Finally, let us decide how we are going to evaluate how good our predictions are. Well, to do that, we have some time-tested measures such as RMSE or root mean squared error, which is the sum of the squared differences between predicted and actual values divided by the number of samples. The lower this measure, the better.